Good day, everyone. We are excited to present our research on the night store problem in a 4x9 grid. This classic puzzle has challenged mathematicians and puzzle enthusiasts for centuries, and our research aims to shed new light on the strategies and techniques that can be employed in solving this problem. The night store problem involves finding a sequence of moves for a knight on a chessboard such that the knight visits every square exactly once. In a 4x9 grid, this problem is particularly challenging due to the limited size of the grid and the large number of possible paths that the knight can take. Our research explores various approaches to solving the night store problem in a 4x9 grid, including heuristic, search algorithms, and game theoretic strategies. We investigate how the competitiveness of the game can affect the strategies employed by the teams and analyze the impact of the order of moves on the success rate and efficiency of the team. Through our research, we hope to contribute to our understanding of the night store problem and provide insights that can be applied to other puzzle and optimization problems. We are excited to share our findings with you today, and we are looking forward for your understanding and good feedback. Thank you. Our research abstract and introduction. The night store is a classic problem in recreational mathematics that involves finding a sequence of knights move on a chessboard that visits each square exactly once. In this study, we investigate strategies for solving the night store problem in a 4x9 grid by two opposing teams. We will focus on the night store problem on a 4x9 grid and explore different strategies for solving the problem by two opposing teams. Specifically, we will investigate how different starting position, move orders, and search algorithms can impact the success rate and efficiency of the teams in solving the problem. Stage 1 are the mathematical situation. Two opposing teams, Team A and Team B, are trying to solve the night store problem on a 4x9 grid. The team take turns making move, with Team A going first. Each team tries to complete the knight's tour by making valid knight moves and visiting each square on the grid exactly once. If a team makes an invalid move or revisits the square that has already been visited, they forfeit their turn and the other team gets to make a move. The game ends when one team successfully completes the knight's tour or when both teams have exhausted all possible moves without completing the tour. The winning team is the one that successfully completes the tour or that has visited the most numbers of squares at the end of the game.
The next are the stages 2 and 3, which is the statement of the problem. It states that the night star problem in a 4-9 grid is to find the sequence to move for a knight on a 4-9 chessboard, such that the knight visits each square exactly once. Following the standard knight's move rule, the knight can move two squares in one direction and one square in another direction, either horizontally or vertically. The challenge is to find the solution that covers all 36 squares of all 4-9 grid without any repetition. This problem is known to be solvable. To finding a solution requires carefully planning and experimentation. As to determine other information about our mathematical investigations, we gathered some related literature about the night star game, and those are: first, the night star problem, a survey by Ian Palbery and William Gassard. Second, the genetic algorithm, the night star problem, by Amit Ud Baba and Muhammad Ahmed Nasser. And then, the night star problem, an analysis of various heuristics by Joshua Yap and Jasper Jewell. And Solving Night Star Problem Through Neural Network by Chin Leung Lin and Wei J. Wu. And lastly, New Result of the Night Star Problem Symmetry and Connectivity by Jacques and Arnold Laboriel.
So now, I am going to discuss the stage 4, 5, and 6, or the investigation proper. So first, before we conduct the game, we need to prepare all the materials needed, such as 4x9 puzzle, 1 knight chess piece, and pen for markings. So how to play the game? Its mechanics consists of making the chess piece moves at once in a L position. We recruit participants to form two opposing teams, each consisting 2 players. The teams will take turns making moves with Team A going first. The game will end when one team successfully completes the tour or when both teams have exhausted all possible moves without completing the tour. We will measure the success rate and efficiency of the teams based on the number of squares visited and the time taking to complete the tour. We will vary the starting positions, move orders, and search algorithms used by the teams for investigate their impact on the success rate and efficiency of the teams. We will also vary the competitiveness of the game by adjusting the rules and the constraints such as the time limit and the number of moves allowed.
So next, we have here our stage 7, 8, and 9, which is the statement and justifications of conjectures. So one possible reason for this conjecture is that the team that starts first has an advantage in terms of making the initial moves and setting the pace of the game. So this can allow them to control the board and potentially block off key squares that the second team may need to complete the tour. Additionally, the second team may be forced to make riskier moves in order to catch up, which can increase the likelihood of errors and failures. However, it is also possible that the advantage of going first is offset by the fact that the second team can observe the moves of the first team and adjust their strategy accordingly. So this can allow them to identify potential weakness in the first team's approach and exploit them to their advantage. So in overall, the conjecture that the team that starts has a higher chance of winning in a nighter game with two opposing teams is possible, but further empirical research is needed to confirm or refute it.
The study of the night tour problem in a 4x9 grid with two opposing teams, several key findings emerge. Firstly, the starting position of the knight and the order of moves have a significant impact on the success rate and efficiency of the teams. Starting from the center of the grid and following a predefined path or pattern can improve the chances of success. Secondly, using the heuristic-based search algorithms such as Warren-Duff rules or a genetic algorithm can improve the efficiency of finding a solution. Thirdly, the competitiveness of the game can influence the strategies employed by the teams, with more competitive games leading the more aggressive and risky move. And lastly, there was a conjecture that the team that starts first has a higher chance of winning, but further empirical research is needed to confirm or refute this. Overall, the results suggest that a combination of careful planning, efficient search algorithms, and adaptive strategies can increase the chances of successfully solving the nighter problem
in a 4 by 9 grid with two opposing teams.